Here is an explanation of how to solve a metric conversion problem. There are many ways to do these problems. This is just one method. You can actually go back and check your answer to some extent with this method, and it's pretty reliable. So let's take a look at a problem. What if you have 834 milligrams of a substance? You want to know how many micrograms you have. So we're converting milligrams to micrograms. The first step is to consider what milli means and what micro means. These are prefixes that we have in the table in the lab handout. So if we highlight those, you see that milli means 1,000th of something, and another way to express 1/1,000th is to say 10 to the negative 3. So when I think milli, I think negative 3. Micro means 1/1,000,000th of something, which is another way of saying 10 to the negative 6. So when I think micro, I think 10 to the negative 6. I'm going to take those exponents and actually write them here on the piece of paper where I'm solving the problem, just so that they're in front of me. So when I see micro, I see negative 6. When I see milli, I see negative 3. Now that you have those values assigned, ask yourself how far apart on, say, a plain old number line are the numbers negative 6 and negative 3. And if you want to draw this out, go right ahead. Draw yourself a number line. Here's a negative 3, negative 4, negative 5, negative 6, etc. So if you count from one to the next, if I'm going from here to here, that's 1, 2, 3 places. There are 3 places apart. Why do I care about that number? Because once I determine how far apart these are, in this case 3, I know that that's the number of places that I have to move a decimal point in order to get the correct answer to this question. So I know that the implied decimal point that's right there has to be moved 3 places in order to get the answer that belongs on that line. But then a logical question is going to be, yeah, 3 places, but does that mean 3 places to the left or 3 places to the right? And here's where I strongly suggest not memorizing anything. If you memorize left or right, or bigger to smaller means left, or no, wait, it means right, I don't know, it's easy to get confused. Rather than do that, try both. If I have 834, again, the decimal point is implied to be right there, and I move to the left 1, 2, 3 places, I get that number. If I have 834, I move to the right 3 places, 1, 2, 3. I'm going to fill in with zeros here. I get that number. One of these numbers is the correct answer. One of those numbers belongs right there, and the other one doesn't. I just have to decide which one. And of course, I don't want to guess. I want to actually decide based on some understanding of this. So if you're wondering, gee, do I want the smaller number to be there or the bigger number to be there? Think about this. What if I said to you, here's a problem. I said to you, solve this problem. 365 days. Obviously, the answer to that is 1 year. What if I said to you, 1 hour? How many minutes is that? Obviously, 60 minutes. Look at what you've done here. In both cases, you've got a number with a unit of measure and a number with a unit of measure. Days are smaller than years. So in this case, the smaller of the units of measure has the larger of the 2 numbers in front of it. That number is bigger than that. The larger unit of measure has the smaller of the 2 units of the 2 numbers in front of it. In other words, smaller unit gets the larger number. Larger unit gets the smaller number. You need a lot of small things to equal one big thing. The same is true here. Hours are obviously bigger than minutes. There's fewer of them. Minutes are smaller than hours. There's more of them. Smaller unit gets a bigger number. Larger unit gets the smaller number. When you finish a problem like we're starting here in this metric conversion problem, you should be able to answer that question the same way. You should wind up with an answer wherein the larger unit has a smaller number in front of it and the smaller unit has a larger number in front of it. If it's the other way around, you got the wrong answer. So let's go back to what we have here. We had come up with the notion that one of those 2 numbers, a very large number or a very small number, one of those 2 is the correct answer that belongs on that line. We just hadn't decided which one. So ask yourself, are micrograms bigger or smaller than milligrams? These are millionths of grams. Those are thousandths of grams. So these are smaller units than those. Micrograms are smaller than milligrams. That's the smaller unit. The number that lands there should be larger than 834. Because if it is, when we finish the problem, we'll be able to say the smaller unit's going to have the larger of the two numbers, the larger unit's going to have the smaller of the two numbers. So of these two choices, I want a larger number. I want a number that's bigger than 834. Which of these is bigger than 834? Obviously this one. So the correct answer to this problem is 834,000. You can put the comma there if you want. Not necessary. That is not the correct answer. This is. And again, subjected to the test. Smaller unit gets the larger number. Larger unit gets the smaller number. This is true here, so I am confident that that is the correct answer. Okay, one thing to note before we try one more problem. If this were the correct answer, it's not, but if it were, and I expressed the number like that, it would be incorrect. The reason is, you can't leave what they call naked decimal points. If there is no number to the left of a decimal point, if there's no whole number that belongs here in your measurement, you have to fill a placeholder 0 there, what some people call leading zeros. You got to add a 0 there. If you don't, the person that's reading your answer might think that that's just a smudge on the paper, or they might not notice that. It's not clear that that's a decimal point. Putting a 0 there emphasizes it. So never, ever, ever leave a value that just has point something. Always fill in a placeholder 0 if there's nothing already there. If you look at one of the links I provided on the handout, you'll see more detailed explanations from a pharmacology standpoint as to why that's so important. So please see that link. So that's how to do one of these problems. Let's just try one more while we're here. This is also a problem that's in the handout. Let's convert 0.4723 microliters to milliliters. So I have this small volume of liquid, and for whatever reason I need to know how many milliliters that is. How would I express that value in milliliters? So again, I'm going to think about my table with the prefixes on it, one that I have here. And I'm going to be thinking of milli and micro again. I happen to be using the same two prefixes in this particular case. And I'm going to assign values. When I think micro, I think 10 to the negative 6 power. When I think milli, I think 10 to the negative 3rd power. How far apart are these values on a number line? We already did that actually. They're 1, 2, 3 places apart. They're 3 places apart. Therefore, I'm going to move that decimal point 3 places to get the answer that belongs right there. So again, I'm not going to try to memorize, gee, should I go to the left or should I go to the right? I'm just going to write this out twice. I'm going to say, what if I start out with this number, that number right there, and I go to the right 3 places, 1, 2, 3. If I do that, that goes away. I'm going to have, I'll write it more clearly here, 472.3. That might be the right answer. I'll decide later. If I go the other direction, I start out here and I go 3 places, I go 3 places to the left. 1, 2, 3. And I put a placeholder 0. So I went 1, 2, 3. Maybe that's the right answer. One of these two is the correct answer. I just have to decide which one. How do I decide? I look back at the problem. Milliliters are larger than microliters. That's a larger unit than this. The larger unit should have a smaller number in front of it. The smaller of the two units should have the larger number in front of it. So a larger unit gets a smaller number. Whatever lands there needs to be smaller than 0.4723. Well, clearly that's not going to fit the bill, but this will. So all I have to do is transcribe this into the line, and I've got the right answer. 0.004723 is the answer to that problem. So again, assign the value, the power of 10, to the prefix in each case, figure out how far apart those numbers are on a number line, and go ahead and move the decimal point that many places. Try moving it to the right, try moving it to the left. You'll get two numbers. One of those numbers is the correct answer. Then just logically decide which of those two is correct. It avoids you memorizing things like go left, go right. Oh, I'm not sure. I'm doing an exam. Now I forgot which way to go. Now I just memorized them all, so I got them all wrong. This way you use logic and common sense to do it instead of memorizing and being mentally brittle about it. And so I think that's the more fluid way to do this. There are more practice problems on the handout, so feel free to try those, and we can go over the answers to those and field any questions that you might have.